Hello viewers, welcome to Codifus. In this video we are going to solve another UGC CSIR net physics question from the last year 2025 December examination. This is the second question in the part C, question number 47. A spherical gaseous ball of radius 15 meter was formed with a temperature around 3 into 10 to the power of 5 Kelvin, around 3 lakh Kelvin. The gas expands adiabatically and its temperature drops to 5 into 10 to the power of 3 Kelvin, around 5000 Kelvin. The temperature drops here. Given gamma, gamma is 5 by 3 for this gas. The radius of the ball becomes approximately like first of all we have to understand this question. Let me open our new screen. So, okay, first of all in this question we have the radius of the ball, initial radius of the ball, R1 is equal to 15 centimeters. Okay, we have the initial thing as 15 centimeters. Initial temperature T1 as around 3 into 10 to the power of 5 Kelvin, which is around 3 lakh Kelvin, which is a very high temperature. T2, after the adiabatic process, we have the temperature as 5 into 10 to the power of 3 Kelvin. Just look at the powers. That is the thing we have to notice here. And we have to find what is R2. After the process, what is R2? We are going to find R2. And there are 4 options given in the question. Let me deep dive into it. First of all, for a theoretical understanding, apart from this question, we should have a theoretical understanding about what things we should have to learn here and there. So for that, let me open another window here. One minute. Okay. Okay, here you can see in the first we are going to take a look at the what is an adiabatic process. Let me write it, adiabatic process. Adiabatic. Okay, the adiabatic process meant by let us consider system. This is a system and there is some surroundings of the system that we consider. These are the surroundings of the system, and there would be a heat exchange between the surrounding and in the system. Like let us consider we are placing an ice cube here on a table. The table is the surrounding, ice cube is here. There would be a heat exchange. If the temperature of the ice cube is lesser than the atmospheric surrounding temperature, the ice would get melt. This is the thing we already know that. And there is a thing that is called non-adiabatic process. When let us consider another scenario. There is another ice cube, there is some surroundings, but there wouldn't be any heat exchange between the surrounding and the ice cube. But even though the temperature of the ice cube reduces or increases, that is called as adiabatic process. Without the dependency of the surroundings, a system changes its temperature is called the adiabatic temperature change. and if the temperature reduces, it is called as adiabatic expansion. If the temperature increases, that is called as adiabatic compression. Okay, if the temperature increases, it will compress. The work is done on the particle, on the system. If the temperature decreases, the particle itself spend his energy to make a work done. So that is the thing. For ideal gas, we have an equation in terms of pressure, volume and temperature, which is called as Poisson's equations. Okay, Poisson's equations. 1 second. Let me type here. I think that would be the better option. Poisson's. Okay, this is here. Poisson equations. Okay, and these what we can do with the Poisson's equations. Once again, let me write the equations here. The Poisson's equation states that pressure, temperature, pressure, volume to the power of gamma, which is equal to constant. Like it is a constant value. It is pressure, volume. Gamma is known as specific heat ratio, which has a value of Cp by Cv. Okay. On our question, you can see this Cp by Cv value is 5 by 3. So here also you can find that Cp is 5, Cv is 3. Okay, this is the thing we got from the question itself. There is another formula, another one of the advanced formula for Poisson's, which is Tv gamma minus 1 is equal to constant. It is another formula. There are two formulas. We have discussed it here. Okay. Okay. Now we will dive into our question. Let me open another image here. View here. One second. Zoom in. Okay. Let me zoom in once again. Okay. We have just got zoomed in. I think here we have written all the values. Once again, here it is. We have written all the values here. So we have to find the R2 value. Okay. To find the R2 value, we have to write the equation T1 V1 omega. Gamma minus 1, which is equal to, this ratio will be equal to T2 V2 gamma minus 1. Okay, we already know that V is equal to, for a spherical system, V is equal to 4 by 3 pi r cube. And we already know there is V1 and V2. This is a constant value. This is the constant value. 4 by 3 is a constant value for each of the sides. So we neglect it. Okay. So we can rewrite the equation as T1 R1 cube omega power minus 1. Same goes here, T2 R2 cube bracket the whole power of omega minus 1. Let me simplify it once again. T1 R1 the power goes up here, 3 omega minus 1 into, okay, this is into T2 R2 3 omega minus 1 into, okay, this is the step here we are going to write. And when we simplify the powers, we will simplify it once again, 3 omega minus 1, okay, which comes under 3 into the value of gamma, I am telling it as omega, which is gamma actually, for minus 1, which comes around 2 by 3, okay. 2 by 3 into here we have 2 by 3 into 3. Okay, here we have 2 by 3 into 3. So we get 3 cancel, we get 2. So let's open another blank image once again. Let me again zoom in. I can get a quarter zoom. Okay, that will be fine. So the formula becomes T1 R1 square, which is equal to T2 R2 square. So we get here T1 R1 square, T2 R2 square. Okay, and afterwards we are going to write this as let me change it. Here you can get a relationship here. In the question you can see when the temperature decreases, the radius increases. So there is a relation here. Or let me write it. T is inversely proportional to R. Okay, T is inversely proportional to R. This is an important relation in this question. That is way too important to understand the concept of adiabatic expansion and compression. So okay, this is the key concept here in adiabatic compression and expansion. Let me write the values first. Okay, for T1 we have a value of around 3 into 10 to the power of 5. We will write it later. We will write the T values later. For R1 we have a value of maybe like around, I think, 15 into 15 square. Okay, and here also T2 is 5 into 10 to the power of minus 3. So we have to also put that 10 to the power of plus 5 here, because for the 3 we have a 10 to the power minus 3 here, 10 to the power plus 3 here, and we should have to find the R2 square. Okay, for here these both have squares, so we can write it as R2 by 15. Here we can write it as square root of 3 into 10 to the power of 5 divided by 5 into 10 to the power of 3. Okay, we are writing is like I will explain it here. We have R1 R2 square by R1 square, T1 by T2. When we cancel those squares, we will take both on the whole square. We get R2 R1. Okay, the whole power. For remove this whole power here, we took a square root T1 T2. We just cancel it. Okay, let me calculate this value once again opening another screen. Zoom in. Once again we will zoom in. Okay, so finally we get a ratio like R2 divided by 15, which the power value comes around square root of 300 by 5, which comes around square root of 60. 60 is almost nearby to 64, which is 8 square root of 64. So which comes around 7.65, I think so. 65 or 75, sorry, 7.75, which comes around the value of 7.75, which is nearby to 8. We are getting a rough approximation. So R2 becomes 15 here. Let me put root 60 and which is means 7.75. Okay, so we get 15 into 7.75. 15 into 7.75. We finally get a value of 116,197. centimeter. Okay, this is the final value. This is the value we have calculated, and the answer is D here. Okay, I hope you have understand the whole concept here. You can watch once again. So if you have any confusions, we can watch once again. We have taken all the values. This is called Poisson's formula. Poisson's formula for this particular question for adiabatic expansion and compaction. We have taken all the stuff here. Adiabatic compression means adiabatic process means what? Even without any interaction with the surroundings, if there is a change in the system, a change in the temperature of a system, which is called an adiabatic process. Okay, we have taken the Poisson formula and other stuff, and finally we have successfully calculated the final result here. Okay, we will meet in another video. I will share a Discord link on the description box. You can join on it, and we will have a quality amount of physics interactions on the group, also in terms of computational physics, and in future I will going to take a class on physics informed neural networks too. Thank you. Have a nice day.